The case of the mysterious behavior of some chemical elements. Sherlock's unique bloodhound-like senses tell him that the famous case of the periodic table of the elements remains unsolved until he thoroughly investigates the singular behavior of some of these residents in the giant building of the chemical elements. Hydrogen, for example, is the head of the alkaline metal group. The only thing it has in common with the rest of the group is its positive valence and the structure of its outer energy shell. By showing its single electron, it seems disguised as an alkaline metal. However, hydrogen is a gas and a nonmetal. A big difference compared to its companions, the most active metals known. In all of the universe, hydrogen is the #1 element. It is the primary ingredient of the sun, the stars, nebulas, and interstellar space. The proportion of hydrogen in the cosmos is greater than all the rest of the chemical elements. But on Earth, it makes up less than 1%. The sun and the rest of the stars shine brightly due to the thermonuclear reactions that transform hydrogen into helium, releasing an incredible amount of energy. The deeper Sherlock digs into the dark corners of this mysterious house of the elements, the more he realizes that his detective skills will be required for quite a while. His fleeting investigation of the behavior of hydrogen uncovers its disguise as an alkaline metal, king of the universe, and the main ingredient of tremendous thermonuclear bombs. On the other hand, the characteristic properties of any chemical element are revealed when combining with others as compounds when electrons are given or received. When an element loses all the electrons in their outer energy shell, the inner shells remain intact. In the case of hydrogen, however, when it loses its only electron, its nucleus is left naked. This characteristic actively controls its particular conduct in these reactions. This explains hydrogen's foolish behavior. This business of the electron shells and the heated exchange of electrons reminds Sherlock of the tragic tale of how the noble gases were banished to the outer group due to their inactivity. The scientists were bothered by these 6 elements who seemed so distant from the sphere of the chemical activity. On the other hand, this exile didn't seem to bother the noble gases in the slightest. Through the years, they said these elements' inactivity was due to the fact that their outer shells were completely full. Therefore, it would be extremely difficult to combine them with other elements or compounds. The physicists, who also tried to explain the situation, established that the outer shells with 8 or 2 electrons are remarkably stable. This characteristic explains their inability of losing or gaining electrons. In spite of their aristocracy, the noble gases showed a true nature for the service of humanity. We use helium to fill blimps and dirigibles, argon for light bulbs, radon for cancer treatment, and xenon for flashlights and camera flash bulbs. An element that couldn't escape the clinical eye of Sherlock is the terrible devastator known as fluorine gas. This element is so reactive that it doesn't exist in a natural state. It's always in a compound. Upon attempting to separate it, many scientists fell victim to its voracity. In 1886, Henri Moissan informed the Science Academy of Paris that he finally succeeded in separating fluorine. A black patch covered his eye at the conference. In the 20th century, scientists found ways to soothe the anger of fluorine, putting it to the service of humanity. The result from combining fluorine with other elements is a compound that is practically indestructible. It doesn't burn or dissolve in alkalides or acids. Even the ferocious fluorine does not affect it either. It is indifferent to abrupt temperature changes, and it doesn't notice the intense cold of the Arctic. This is also the situation for the refrigerant called Freon, where fluorine is the principal ingredient. Its chemical name is quite difficult to remember if you don't learn the art of the tongue twister: dichloro-difluoromethane. Other fluorine compounds, available thanks to the tenacity of the scientists, are used widely for humanity. They are known as fluorocarbons. They are used as liquid refrigerants and cleansers of sensitive equipment. And they helped the noble gases lose their reputation of being inert by combining with xenon to form a fluoride compound. The great division of metals and nonmetals in the House of the Elements has also been a source of investigation for the scientists, so that Sherlock doesn't fall too far behind. He dedicates a good while to his own investigation. When two elements begin to chemically interact, the outer electron shells of their atoms are rearranged. One element offers its electrons, and the other graciously accepts. The difference between the metals and the nonmetals lies precisely in the conduct of these elements. The nonmetals are quite fickle, flexible, due to their general rule of accepting and offering electrons when it suits them. Only oxygen and fluorine behave in a stubborn manner by only accepting and rarely giving electrons. The metals are much more persistent in their tendency. Their motto is, give electrons. Sherlock is totally confused by this issue of giving and taking electrons. So some elements are very generous about offering and receiving electrons, while others, without too many theatrics, take electrons as they find them. In general, the elements whose outer shell has only a few electrons tend to lose them or share them in order to form shells of 8 electrons. That is why the noble gases are so stable. That is also the case with the alkaline metals, with a single electron in their outer shell. It's of little importance to them to lose it the first chance they get. On the other hand, those elements with many electrons in their outer shell prefer to graciously accept electrons to complete their orbits. Like in the situation with the terrible fluorine gas, who practically rips away any electron it can to complete its orbit. Other elements of the great house exchange electrons with more or less difficulty depending on the number of electrons in their outer orbits. This ability of the elements to combine allows them to form compounds that are very useful to people. Sherlock is highly impressed with his skills at cracking mysterious cases. When it comes to forming compounds, he finds the attitude of the chemical elements very extravagant, and of course, he is amazed by the scientist's determination to study and learn about the secrets of nature.